that if I increase the strength by a factor of 3, which takes me up to about here, I also increase the weight by a factor of 3. Now, if I plot in the O piles in comparison, if I take this point here and I increase the strength by a factor of 3, which takes me up to a factor of 4, takes me up to here, I increase the weight by 10%. Just think about that. In the conventional system, we've increased the weight by a factor of 3 to get a strength increase of 3. Here I'm getting a strength increase of 4 times the capacity, for 10% extra weight. That's the efficiency. That's unmatched in the industry. So I can easily bring in comparison systems, king pile against O pile, and all I have to do is from this point go left and upwards to go less weight and higher strength, and you can save easily 30%, 40%, 50% on weight in comparison. So that's the efficiency. And then you have to look at the in-use value. This is a software package that compares the construction costs, not just the material cost. If I compare the sheet pile to the oak pile, I have all these advantages that you can see here. It's 3% stronger. Down here is overall 4% cost saving through the construction sequence. If I do it with a king pile, I have 4% stronger, 11% less tons, 27% lower install cost, because it's easier to construct this than it is that. Overall, you have 11% cost saving, and if I go to the heavier systems with heavier pipe, I have the same type of comparisons all the way through. That's actually a very valuable cost differential when you're constructing a project. There's one other advantage I just want to touch base on, and it's the durability of steel. Everybody thinks steel corrodes and concrete lasts forever. Well, let's just get one thing clear. Concrete breaks down, and it has to be replaced. And here's what happens. Concrete is porous. It's not solid, it's porous. And over time, carbon dioxide gets into the pores, it gets to the steel, it changes the cement paste to calcium carbonate. Sorry for getting so technical, it's just for a little bit. And that calcium carbonate changes the pH in the cement mix from a high alkaline 14 down to a pH neutral of about 7. What that does is it makes the steel in the concrete start to rust. And the rusting steel starts to expand. It's called carbonation. And it spoils the concrete, and it leads to this failure here. That's the process. And you see I go to ports all the time and I look at these structures. This has failed. This is a failure condition. This has failed, but it's tied up with a piece of rope, so it's probably okay. You know what I mean? But once this process has begun, once carbon dioxide gets into the pores, and this has begun, it's the end of the life of that concrete structure, very, very soon. So, it's so bad in the northern part of the northern climates, because of de-icing salts, because of winter conditions, that they will use cathodic protection in concrete. Now, usually cathodic protection is just for steel, but they use it for concrete to extend the life. When you come to durability of steel, the number one option for the engineer is always sacrificial thickness. If your corrosion rate is 1.1 millimeter a year loss, and you want a 50-year design life, then you have 5 millimeters of sacrificial extra steel to put on the structure and just allow it to corrode away. 50 years time, you replace your structure. That's how it works. If you can't get it with sacrificial thickness, because you can't get a section thick enough, then you go to coatings, you use marine grade steels, or use cathodic protection. That's what the engineer does. Sacrificial thickness is fantastic, except it has one big drawback, and that is you sacrificially protect all the steel, you add thickness everywhere, but you only need it here. You only need it in the splash, in the low water zones, the tidal area on a marine structure, but you're putting it everywhere else. And that's very costly. prohibitive. If you could do just this, you could save a lot of money, and it would be a far more cost-effective option. There is a way to do it. Funny enough, it involves the O-pile. And here's how it works. So here's your marine structure. Here's your pipe wall. But down here, you have a fabrication. And what you've done is simply this. You have a thicker top pipe to meet the requirements in that splash and low water zone, and at the bottom you have a thinner pipe that meets the structural needs all the way through. So you haven't got that extra sacrificial thickness where you don't need it, you just have it at the top area, and that keeps your costs down. It's a simple structural weld. That weld is usually below the seabed where your stresses are low, where the corrosion effects are low, and it becomes a very effective, simple system. Now I've costed out an actual project example using that standard sheet pile on a 300-meter wall, 25 meters long. I came to 1,900 metric tons. In a conventional solution, I would have used the sheet pile, maybe a steel grade enhancement, and maybe a coating system, and this was the cost. Maybe I used Cathodic Protection instead of the coating, and the cost changes a little bit. Maybe I use a different steel combination on a coating, and I get a different cost too. And then I looked at the pipe to pipe. I looked at a 914 by a 16 millimeter on the top with an 11 millimeter thickness on the bottom. And costing that out. And by the way, to do these evaluations, there is a tool that's just been released about a year ago. It's called Ice Sheet Pile. It's a free software, and it's absolutely innovative. It allows anybody, a contractor, an engineer, somebody who wants to evaluate systems, to pull up systems like this and to get all the properties of them there and then. There's no other place on earth you can do that. So this is a really innovative piece of software. iSheetPile.com, it's staggering in what it can do. But from all of these, I can simply take the properties, I can feed them in, and in this solution, with the pipe to pipe, including the fabrication here, I came up to this figure. And these are the cost savings, just on the material, just on the material equivalents. And then I can look at the installation cost differences, and you can see where your cost potential comes out. So targeted sacrificial thickness gives an economical solution without the need for coatings, without the need for special steel grades. It's just the basic steel, and that's the best way to get a durable structure.